So last time we made some really good progress on the enclosure, and we also got to give you a demo of all of the different functions and what they do. We also found out there was a little bit of a problem. Change modes? No. Okay, locked out, and if we come back, oh, we still can't. What's happened here? Alright, we have another bug. Yeah, I've done a bit more digging since, and unfortunately it's not a bug in the software. The software's fine. It's something in the hardware. It's my favourite task. Yeah. Electrical interference. Let's get started. Okay, so I've done quite a lot of investigation into the issue and I've ruled a lot of things out. I still haven't fixed it, so let me give you an overview of where we're at, including explaining why we've got cables hanging all over the place. And I don't know, maybe it'll trigger a thought as to what's going on, but I'll show you what I've ruled in and out and what I think is going on. Okay, so last time I didn't have this wire directly connected to the Arduino like that. That was removed from there, and instead I'd had this green wire from there onto, I can't remember if it was ground or 5 volts, whichever way. I actually tried both ways and moved the jumper across just to see if that made a difference. Now when it was in that configuration, as soon as it got power, 5 volts here, which was while this was booting up, the relay clicked on and the brake for the stepper motor was then energized, so it was released, and then the stepper would be free to move up and down. So by the time this had fully switched on, and it takes a few seconds just to boot up, this was already on, and actually in that condition it would work fine, 100%. I think you might remember when I hit the E-stop though, everything shuts down. It shut this down as well, and in that example that I gave there, it messed up the screen and this stopped responding. So my first thought was, well, this is running off 5 volts, which runs off this 5 volts, which is the same 5 volts goes in the Arduino. Maybe, I know this is opto-isolated, but maybe something is still not happy in there and there's still a little spike getting through or something like that. So first thing I just checked, I went online and had a look at the wiring diagram for these modules. Now it turns out there's a couple of different varieties. I'll get into that in a minute, but essentially they've all got a little flyback diode. You can't see it really, well you can, but it's very, very small down here on the board. And that is across the coil, so that should be limiting any of the spike you get when you energize or particularly de-energize these. It's also got an opto isolator between the control signal and that, which is helping, but don't forget in this case I'm powering it off the same 5 volts that goes into the relay as goes into the Arduino, so essentially there was potentially a route through, and I wondered if that was causing a problem. Now you can get a few different types of these. This is more basic, you've just got the high and the low triggering. Some of them have got a jumper so that you can pull that off, and then the 5 volts or whatever supply you put in here can be different to this side here. It kind of isolates the two, so they're completely independent, and you can have an independent power supply. This doesn't have that ability, unfortunately, but it turns out from what I've got so far that wouldn't have helped anyway. So at this point I disconnected it and I got it permanently wired in, and that worked fine. So then I tried, rather than, again, the Arduino is not connected at all, and I've got my little flying lead. I've got that hooked into that relay module, and this time when the door was down so I could operate the buttons, I had my hand in here and I could ground it like that and trigger the relay to trigger the stepper brake. Now it would do that once or twice, but after maybe 3 or 4 times of doing that, or sometimes less, it's a bit random, the Arduino would just stop working and have strange characters on the display and it wouldn't respond anymore. So, don't forget I'm not connecting it via this little cable anymore. I'm still using a little flying lead and manually just doing that. So what that was telling me was that it wasn't the communication through here to draw that pin low to switch it on. Still, potentially it could be a spike coming back through here through the shared power lines. The 5 volts went into each of those, so that's possible. And I thought before I go and put another power supply in here, I thought I'll just check, just in case there's any EMF or anything like that off the main. These are the main power cables. So this connection this is the where the common and the normally open get connected. So this is where your 24 volts goes down. It comes down here through the power supply and goes out to the brake. So in case there was a bit of a spike or whatever through here. I pulled this all the way out of the way, going nowhere near the other power cables, but no difference. So possibly or probably not coming through here, so it must be something else. Now at this point I was going to get my oscilloscope out and start probing around and see if we could find where the spike was coming back. Assumed that was still what the problem was. Being a bit lazy, it's up there on the shelf and it's nicely put back in its box, all the cables all nicely tidied up. I thought, oh, do I want to get that out? I don't know. Let's see if I can at least deduce what's going on. A few more tries, and what I ended up doing, it's on the floor, don't know why I didn't think of this first. These are the two pins that go out to the big solenoid on the stepper brake, and I just removed that. What does that mean? Well, it meant that when that relay clicked, it would just click and there'd be no spike, no current draw, no solenoid activated. And don't forget, I've got it hooked up to the Arduino again. I ran that for about 5 minutes, up, down, pressing the buttons, e-stop, absolutely 100% worked, no problem at all. So at that point, this is about 1 or 2 hours later, because I redid some of the wiring. Oh, I did something else as well, we'll get onto that in a minute. Right, so now we're getting somewhere. It's obviously, once that 24 volts, the relay clicks shut, it's sending a big surge of power into the stepper motor brake, which is under there, and that's a big electromagnet, or a solenoid. I guess electromagnet is probably the correct term, really, isn't it? Big coil in there, and it's quite a thump when it goes, because it's got to overcome the spring pressure and apply a lot of force onto that friction material and overcome the ability of the stepper to turn it. That's the whole idea. It's like a brake. So it's a big, violent event, and obviously that's enough, that sudden rush of current, whatever, to put a big spike through the 24 volt side of it. So relay closes, 24 volts comes out of here through the positive. It goes, I think it goes up to the relay. Obviously that relay is now shut, it comes back down, goes out to solenoid, comes back and goes to 0 volts DC on here, and does that with, obviously there's a big spike in there, and when that's obviously what's tripping it, because if you take that out, works fine for many minutes, trying the buttons, no problem at all. So that's what I've got to solve. You'll notice some other things down here. So you might notice down here I've also got 2 flyback diodes. It's a bit small, but it's the first one I grabbed out of the box. That's going across positive and negative on the 24 volt supply, and for good measure I put one across the DC on the 5 volts as well, but that made no difference at all. So I just thought that might be a quick fix, just in case it was spiking back through here. Okay, so just to prove that out beyond any doubt, what I'm going to do now is take the live, neutral and earth off the 24 volt supply here. Obviously just tape those up, so because they'll be live now and floating around, and then run it from, got it somewhere, where's that gone? Where is that? Here it is. All right, I'll just make up a little cable from this, crop those off, and connect those up to there, and then run this from I don't know, like a 20-30 meter, 25 meter, there we go, extension cable to the far side of the workshop. So basically try and put as much distance between the live that goes into here and here as goes in here, and it'd be like a kind of inductive coil, capacitive line. Essentially it should soak up a fair bit of that shock. Well, hopefully it will anyway, and if it works flawlessly like that, okay, now we've got the problem solved. Don't need to break out the scope, but then I've got to figure out how I'm going to fix that. Alright, so let me wire this up and let's see if it works. Alright, so we've got our extra bit of flex here, hooked up to the 24 volt supply, got the 25 meter extension cable, and that is plugged in over the other side of the workshop. So I guess the order is that critical. We'll turn the main supply on first, and then we'll turn that one on. Okay, so far so good. Yeah, shouldn't really be any different. We're just running it from a different supply. Okay, so I think we'll plug the brake in and then see what happens when we move it about. Now, I've got to be extra careful around here now, because the live and neutral that were in there, they needed to sort of daisy chain and carry on down that end, so they're under this tape here, one buried in the cable guide. So being careful not to go anywhere near that. We can plug the brake in. Okay, that's all good, and that's wired in correctly. Right, I think that's it. Let's give that a try. Just for fun, let's just reset the Arduino. Okay, and go down. Okay, so it's doing a lot better than before, though I did have that issue just a moment ago. So, oh, it's gone. Alright, so maybe that's encouraging. It's a lot better, but it's still, yeah, that's locked up again. Onward. Okay, I've been playing about with this for a few minutes now, and I'm really struggling to get any kind of spike, anything like that. I looked at the DC and the AC part, zoomed in, trying to take a recording and zoom in, find something unusual, but it's generally pretty flat. It has a little bit of noise, but nothing untoward, so maybe it's not spiking on the 24 volt DC part. So currently got it probed there just across that diode, so we've got the positive and negative side of the 24 volts DC, and every time the relay clicks, I've been recording it but struggling to see anything. Okay, so now I'm just probing across the 5 volt supply. That's the supply that goes into the Arduino, just to see if a spike appears on there. That's anything I can kind of think of, so I'll set that up. Okay, so I spent quite a long time with the scope, just trying to find out what was going on, having a look to see if I could find this spike that was occurring every time the brake was triggered. Tried different configurations, plugged in an external power to reroute the 24 volts into a different part of the workshop, so to try to separate everything. I've also got the Nano hooked up with the USB powering it via its own dedicated supply, so it's not drawing on the 5 volt supply. In fact, the 5 volt supply wasn't actually on. Just trying to isolate different bits of the circuit, and this is kind of where I've got to. So yeah, lots of cups of coffee later and lots of thought later, I got to this point. It's better, but it still does trip out, so still not perfect. We've currently got the scope just having a look at the metal plate down here that's earthed. Now I do have the main stepper motor cable, the outer sheath of that is connected to this, which is all connected to the star earth, so maybe there's some noise going through the earth system, I don't know. That's possible. I could try just disconnecting that. I had good success doing that on my ELS project when I disconnected the outer sheath there. There was some kind of ground loop going on. It's possibly that, but let me show you some of the other stuff I've got hooked up then, and where we got to. Okay, let me just close the lid. You probably can't quite see the display up there, but it's running, and if I click, now the motor won't run to lift the knee up and down, but we should hear a loud click from the relay, or from the solenoid, sorry. That's it up. Oh, two things. One, yeah, okay, it stopped working after about 5 or 6 goes, but also on the scope, when it tripped, I saw a massive spike. This is looking on the earth, so that's looking likely. Okay, so we're getting somewhere. Let me reset it and we'll keep recording that and just see if we can capture that again. So I'll do a reset. I can see one now, I guess. Oh, that was okay. It's still running. Oh, there. Has that stopped it? Oh, no, that's still working. Oh no, it's gone. Alright, so maybe we're getting somewhere. Okay, I've disconnected the outer shield that goes around the stepper motor cables. That was onto this metal plate here, which is also connected to Star Earth. The 24 volt supply that goes out to the brake is through here, but I made sure that the wire on the outside and this one, they don't touch the casing. So, you know, I looked ahead and I thought, yeah, I might want the option of isolating these from this ground plane, if you like, here. So let's see if that makes any difference. Okay, and it's, I know you can't see it because I'm trying to get you in shot with the scope as well, but that's running okay. I saw a little spike there. Yeah, more spikes, but every time it's spiking, it's not... Oh. Spoke too soon. Okay, well, I've tried lots of different things, isolated different circuits. It's getting better, but still not 100% fixed. So I was about to swap out the relay board. I've got another module board here. So these come in different types. Obviously you've got the different voltages. I'm using 5 volts here, but you can get 12, 24 and so on. And that's the voltage for the coil. Obviously they're always isolated on the outputs in terms of what you want to switch. So this one's got 2 relays, so you've got a common, normally open, normally closed, so that's the same on all the modules. Where they differ is how you power them. So this one's actually got a jumper on it, so you can see there, at the moment it's in that position, so the voltage that comes to this to power the optocouplers, to trip those, is shared, and it's the same voltage that gets used to drive the coil. Now, in most cases that's probably okay, but it does give you the option to separate those, so you could have the coil driven off a different 5 volt supply to the 5 volts that comes in and runs the optocoupler that's the same on the same circuit as the Arduino, so you can kind of separate the Arduino not only from the signal by the optocouplers, but also the power that goes to the optocouplers and the relay, separate those as well. So I might try that. Obviously I've got to make up some pins and whatever to do that, but before I do that I thought I'd try one more thing. So I know it'll put a little bit of rise time in when the solenoid actually clicks on. Maybe I can deal with that. So what I've got here is a little RC filter. So I've got 100 microfarad capacitor between the positive and the negative, and then I've got a little, I think it was a 220 ohm resistor. So effectively this is about 8 Hertz low pass, something like that. I've also got the scope hooked across that capacitor, so we should be able to see the spike and the rise time, and just maybe have a look and see what's going on there as well. Let's just press the buttons and see what happens. Okay. Clearly that triggered okay. It didn't operate the solenoid. Maybe the current limiting's too much. Let's just try that again. Okay, well it's certainly working in terms of giving a rise time, but maybe the resistor's too high. Oh, I need to play around with that. Right. Okay, I've just swapped out the resistor for a 10 ohm resistor, so this will be 160 Hertz low pass, so it's a lot higher, it'll charge up a lot quicker. I just wonder if the other resistor was making good connection, because when I tried to put this one in it was quite loose on the terminals, so I've just folded the wire back a few times and now it's nice and tight. So if this works I might go back to the other one, but anyway, let's see what happens. Right, let's just press up or down. Okay, it's operating the relay, but well, I didn't put the I didn't plug the scope back in for one, but it's not operating that. Let's just let's just make sure it's working. Hold on. Right, just a bit of testing off camera, and any level of resistance based on any resistance I've got, yeah, it was never going to run enough current through there, which I did worry was going to be the case. I could have worked it out, but I thought it was quicker just to try it. So I think the lowest I went to was 10 ohms, and even that was too high. Now I do have some very, very low resistors, but they're the kind of high power type, and I thought, well, I'm not going to mess about with those. So I basically just got the capacitor across plus and minus. So the only resistance it's got in the circuit is just whatever the few milliohms is in the cable. so that's dictating the rise time, and then obviously the resistance is low enough so we can actually operate the device. So let's give that a go. Press one of the buttons. Okay, so it triggered and we got a nice rise. I'm going to guess we ended up at 24 volts. Let's just have a look. Yeah, it looks like it's going to be close. Yeah, nearly 24 down there. Alright, and then rise time, call it there somewhere, 44 microseconds. So yeah, it is filtering off, so let's just try that and see if it's stable. Okay, so that's all, yeah, it's all working. Let's just press up a few. 2, 3, 4, 5. Let's count. Let's do down a few times. I think we might have cracked it. That's encouraging. Now I guess worst case is obviously there's a slight delay in releasing the stepper motor, and if it tries to power it, once it does that it might lose a few steps if it's trying to power it while the brake's coming off. So I guess I can do that in the code, just give it a very slight delay. The only annoying thing is getting that balance between when you press the button, especially if you're just pushing it momentarily, it's never quite going to get going, and that's going to get annoying. So it's going to be a bit of a trade-off potentially. Anyway, it's got to work, that's the main thing, so I'll have to just work with that. Right, let's put, I forgot where the power supply's gone for that, where I'd got to. Right, let's get it all running as it was before and see what happens. Right, so 48 volts on, running from the big extension cable. We've got 24 volts on, running from, no, hang on, no, the 48 volts is running from the wall socket up there. Next to it, we've got the 5 volt supply, it's running to the Arduino, so that's separate. The 5 volts on, but it's not going anywhere, it's not doing anything, and the 24 volts is running from there, and we've got our little filter capacitor down there. So let's give that a try, and then you can slowly work some of these things back. So run this off the inbuilt supply and so on. So anyway, let's not get ahead of ourselves. Let's see if this works. Okay, that was looking good. Let's change out some of the wiring. Right, everything is back together as it was before. So we've got our single power cable coming in, powering the 48, 24 and 5 volts. That's running the Arduino. And then I've just got a direct link out of pin 5 that runs out rather than that resistor. So that's, as it really should be. We've got our link pin back in, so everything here that's 5 volts is running off this 5 volt supply, which all comes off the same single input there. We've got our little shield reconnected for the motor. I don't think that's going to do too much, and then I've rerouted all the wires back because some of them were out just down the side here, all lying on top of each other. Everything's been removed there. Oh, it looks like I've still got that diode there, flyback diode. I guess that's gonna not do any harm. I'll try it without as well. And there's nothing here, and we've still got our capacitor on the cable down here, and we've got the scope looking across there. Right, this should work. Okay, let's go down. Okay, working as before, 21 microsecond rise time, so really fast on that. I guess most of the reaction time then is going to be the inertia of the actual solenoid moving itself rather than the current rise. the voltage rise, so I think that side's okay. Does it go up and down like it should? Try a bit faster. Yes, finally it's working. I've lost count of how many hours I've spent chasing that little one down, so all it was in the end was that capacitor. So it's now all working. Right, I think what I need to do now is have a peek tidy up, because I've got wires and extra cables and all this stuff out here. Tidy that up and then see what I'm going to do next. I can't even think where I'm going next. I'm so happy I've got that working. Okay, so it's time to make that capacitor modification permanent, and for that I 3D printed this little block here, and that allowed me to make a nice little connection to the capacitor unit and have it all inside the enclosure. So to do that I use my heat insert press, so I'll put a link to that in the description below so you can check out the build video on that. So as you can see, I've made a modification. So in the original design I had springs pushing it down, and the idea of that was to try and get a repeatable process, but I didn't really like it. It didn't repeat very well. It tended to overheat the insert. So I've gone with one of the suggestions in that video, which is to actually have it pulling up, and I've just for now got an elastic band on there. That seems to be working quite well. I also went and bought some of the proper inserts. So I had some comments that I'd bought the like injection molding inserts before. They weren't quite the right type. So I've got some M3, M4, M5, M6 and maybe Quarter 20. Can't quite remember if I ordered those. I think I did. And they've all got that lead-in shoulder. And then rightly or wrongly, the kind of technique I've settled on is to just get the iron touching the insert and then get a little bit of heat in it. And then when it starts to move, just back off and just pulse it down, just so you get a feel for, you know, that trade between having enough heat and pushing enough pressure, especially with these small ones. And then right at the end, when I've got about 0.5 millimeter to go, I turn it over and just press it flat on the plate. So then it's going to go in nice and square, it'll be flush. And that process, yeah, seems to work quite well. So let me know in the comments if you're not happy with that idea, but it does seem to be working for me anyway. Okay, so I've got a positive feed here and then the switched feed here, and I'm putting the capacitor across there so that once the switch is made, the capacitor's after that, so then the inrush will come in and this should calm it down a little bit. Alright, it's time to tidy up the wiring in here, so I thought I'd just 3D print this little box here, and then we've got some little wire guides at the bottom, so this will go in there, and then the wires for the motor and for the brake will come through there, go into the bottom there, and then got one of these standard connector blocks, so that will go into there, bolted in, and then you'll have access top and bottom to put the fixings in, to put the wires in, sorry. Yeah, very like that. And then all that will be hidden behind the cover, and the wires will come in here and connect to there. Alright, let's get it installed. Okay, you can see the limits now in shot here and here, and you can just about see the display. So let's go up and see what happens when we hit the top one. Okay, obviously we've got a little bit of debugging to do just on the Arduino for that, so it's obviously trying to print both at the same time, but it won't allow you to go up. Can we go down? Yes we can. Alright, let's see what happens when we hit. Okay, yeah, I need to clear that bit of the screen, don't I? Alright, let's keep going down. Again, it's saying lower limit hit, but obviously it's printing both at the same time and flicking between them. So can I go down anymore? No. Can I go up? I can. Okay, I need to clear the screen. Alright, still debugging, but it does actually work. The other thing I've done is just turned up on the lathe these little feet here. Now I didn't quite have enough stock to make these fully, or the full length that I needed, so again went on the 3D printer and printed these kind of feet. I'm really pleased with that finish, it's amazing. Now the only thing I noticed is that, like, seam. I've seen lots of videos on seam lines and hiding them and so on, but I've not seen them on any prints, maybe because I haven't done any large cylinders, but yeah, I can just roll that around to the back, no, I won't see it. And that, as you can imagine, it's got, like, you probably can't see in there, there's a stop at the bottom which is about here, that this will push against, and then it's sort of castellated in here. There's kind of ribs that go around, just so it's not making 100% contact. I think there's like 3 contact areas, just hopefully. I haven't tried this yet, let's, yeah, should make that into a nice fit. Right, yeah, bottomed out, and then that goes in there. And it's going into the nut that's in that 3D insert there, or 3D printed part. Now this is obviously PLA, maybe with this load on it over time it will creep, like some of the other things. I'll replace it with PETG, but for now it's in. Let's rotate it so the seam lines around the back. Alright, let's do the other side. Okay, similar thing this side, there's a little nut inside the moulding and it just takes the load up the side. Okay, so when it's up against the wall like that, this will be sitting on the workbench, and then at the back there's some standoffs just to pull it away. See from that kind of plinth there, it's about 10-15 mil away from the wall. So I've got these little insert plugs, so that will go against the wall, that goes into the back of the board and it basically spaces it off. So when I screw all the way through into the wall, this will hold it off a little bit away from that, and then this will sit on the main worktop. Right, well, there it is, essentially complete. There's a little bit of debugging to do in the software just to clear that limit error and just to make sure that screen looks a little bit nicer, but all the hardware's done, so I think we can close that up. Something I'm missing. I haven't put the magnetic catch on. Okay, we'll just tape it in place for now and see what it's like. I was just looking for some clips to secure the wires and I only had these two left, and also they're only designed to put a single cable in, and obviously I've got two, so I could have waited a few days for them to come through eBay, or got a 3D printer. Designed and printed these, each one, well, printed a few in about 15 minutes I think, design about 20 minutes, so super quick. Right, let's get these installed. Okay, we'll switch on and you can just about see the DRO in that corner there, so both should come on now. Okay, let's make sure it still goes up and down. I think there's a new problem. Okay, what's happening is the ball screw is actually spinning in a little holder at the top, so it's only got a screw into the end of it and it's just like friction holding it, and if this spins with the ball nut then the table won't go up and down. Okay, so I'm probably going to have to take that bracket off there, modify it so it's got a real clamp, or put a flat in it with a grub screw. Basically I've got to lock this solid to there somehow. Anyway, although that's slipping, let's see if we can go up and down still. No. If I hold the ball screw, yeah. Okay, we need to fix that. So before going into CAD, I thought I'd have a little look at what we've got at the moment. So here's the current part, and well, a couple of things. It was far too thin to put a grub screw in. There's only 3mm of area on there, so it was almost going to break through this surface. Second thing is, now I've got these slots, I now know, based on the machine, all the tolerances from sort of the base unit all the way around through some parts that aren't mine, you know, so I didn't draw those, I didn't machine those. There's 5mm difference, so I now know where the holes have got to be, so I may as well put them in the right place rather than have slots. It's a bit quicker to drill a hole rather than the slot. And essentially just made some reference measurements off that, kind of what I want it to look like. I want it to be thicker, and then I'll machine the ball screw end so it's a little bit longer, so I've got more to bear on with the grub screw. Make the ball diameter a little bit wider, just so I've got room to countersink these screws and have a nice bearing area. And then before I made it, I decided to 3D print it just to make sure it was going to fit. I had a pretty large bit of stock, but I just needed to face it, drill the hole down the centre, and then get the OD to the right size. Then I took it over to my bandsaw, cut it slightly longer, put it back in the lathe, turned it round, faced off the other side to the right thickness, which I think was about 15mm, and then that part was done in terms of lathe work. Then it was over to the ball screw. Now the parts where the balls run is hardened, and it always puts up a bit of a fight on the lathe. I can't really get underneath the hard surface because it's just too deep, so I just have to take my time on it. I usually end up with a chipped insert, which I might have done in this case as well, but taking it steady, bringing it down to the right diameter, and then I think I took it down to 7mm in length. The only thing is now, To put in those two holes and drill that set screw hole down there, I really need the drill. So I need the table and the knee to work, because I need to get it into position and hold it, stop it sinking. So temporarily we're going to get this one back on. I'll just put a bit of tape around the ball screw just so it's a tighter fit on that, and hopefully that will do us. So I've just packed it out a bit, give it a little bit more friction. I'll put this in for what will hopefully be the last time. Okay, I think the first thing I'll do, I'll put the countersink in there, then I know which is the top. So it's just got to suit that to make it flush. And we're a little far away, but that's okay. We can go up. Okay, we're centralised over the hole, so here we go. Okay, now because we've countersunk that and we've zeroed on the DRO, we know where 0, 0 is, so that saved me edge finding. Now I'll just put a 6mm spot drill. We can move to the coordinates and spot that out. However, slight problem, we can't get it in. Looking forward to this for a while. Right, I thought I'd stop here because I want to try something. So I've just put some WD-40 on there. There's my reamer. I've drilled it out to I think 5.8. So what I'm going to try and do is have the knee rise up very slowly and just nice and smooth, and read that out to the final size. So we'll slow it down and see what happens. Well, for one, that cheap reamer's got quite a lot run out, so yeah. Anyway, that's what we've got right now. Let's go. What we could do. Okay, I've drilled it to 4, so what we'll do now, we'll just counter bore it with a 5, 18mm down, and then the last bit should leave about 8mm. We'll tap that, we'll drill it 4.2 and then tap it M5, so basically there'll be clearance for most of it, and then last 8mm will have a thread. I'll have to see how we go in terms of if we got enough thread. If not, I'll just open up the top a bit. Okay, and here it is all finished. Got our nice counterballs there, offset. Our main screw through there. Little counterbore tapped hole, and you can just about see I've got a grub screw in there, ready to go. So I think all we need to do is lift the knee up, put a load of that wooden packing in there, take the old ball screw mount out, fit the new one, and hopefully that will be that. Now I didn't realise it when I was filming this and drilling these holes, but these counterbores are on the wrong side. Anyway, so when I came to assemble it, I just put the original screws and washers back on. I didn't even notice. Just when I was looking underneath, I thought, hang on a minute, I've counterbored the wrong side. Oh well, it's still going to function just as well. Okay, so rather than end the video there, let's actually drill something. So we'll use the knee to move up and down and drill a hole. So I've got a scrap bit of material here. As you can see, I've had lots of holes drilled in it. So we'll drill a 5mm hole straight through with no pilot. And then let's see how we get on with a 10mm hole straight through with no pilot. And this is about 20mm thick aluminium plate. So let's see if it'll do that. Okay, so we'll mount it in the vise. Don't have to pick up off any edge. I'm just going to drill a random hole, but obviously we're going to need a bit more space than that. Now this is currently set to, the speed is set to just percentages of, so about 100% is about as fast as you can go at the moment. I don't have any acceleration built in, so it goes straight to full speed. So there's probably a little bit more performance we can get. The other thing is I want to put millimeters per minute in terms of the traverse speed, so it's a bit more like a CNC machine rather than just an arbitrary number. But we'll get to that in a future video. Right, let's see if we've got space for the 5mm drill. Yeah, it looks like plenty. I'll just make sure we're definitely over some fresh material. And go up. Okay, here we go. We'll raise the knee and see what happens. Ambitious going all the way through in one go. Now we're through. Step down. So we'll move it over so we're in fresh material. Okay. Okay, ready to go again. I think this time we'll pack it a little bit. Turn the speed down. Okay, well I think I'd call that a success. That's 10mm, no pilot through 20mm of aluminium. Yeah, no problem at all. It didn't feel like it was strained. I pecked it a little bit just to stop it clogging up and let the chips come out, but that's normal anyway when you're drilling. Yes, felt like I had plenty of power and probably more to give as well. Okay, so I'm pretty pleased with the progress made so far. So we managed to get the control box finished. Some of it works. Okay, there's a little bit of debugging to do and some extra functions to add, but the basic functionality is there. We've got it wall mounted, we've got the legs finished. I got all the cover plates 3D printed for the belt and for the motor. Pretty pleased with the 3D printed little brackets, sort of custom wiring clips. They work really well. And then we got the wiring in, didn't we, for the inputs for the lower and upper limits, stepper and brake. Oh, and I also managed to make a little catch for the door. It's just a little wedge shape that just jams against the bottom and holds the door shut. Also holds it nice and square and aligned to the main frame. So with that, I think that all remains to be said is, as always, thank you very much for watching. Hope you've enjoyed. If you want to see how I get on with the next episode, feel free to subscribe, ring that bell icon so you get notification when I upload, and see you next time.